Hello students, so today we'll study chemical bonding and molecular structure question part 2. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owner of these images. If you are the owner of any of the images used in the deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So what are we going to do today? So we are going to practice questions from 9 to 15. So that is giving us total of 7 questions. So we'll go through these questions. Question number 9. Question number 9 says that the correct statement for the molecule CSI3 is, options are A, it is a covalent molecule, B, it contains CS plus and I3 minus, C, it contains CS3 plus and I minus ions, D, it contains CS plus I minus and lattice I2 molecule. So this is asked in question in J for May 2014. You have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, what is the question? So the question is asking that you have to write the correct statement regarding CSI3 molecule. And the correct answer is B. How? So see, this is means how does CSI3 exist? This is been asked here. So basically, it exists as I3 minus. Okay, so it is made up of I2 and I minus, which is linear in shape, and the CS plus is an alkali metal cation. So why is this question asked? First of all, cesium is something which is capable of donating one electron only, okay, because it falls in the group of alkali metal. So the counter ion or the counter anion should also have a charge of -1. Now, if you consider CSI3 as a formula, as a general one, that I is existing independently, then in that case, you have to give cesium a 3 positive charge to keep the overall compound neutral. So that cannot be the case because alkali metal cannot go to +3 oxidation state or cannot lose 3 electrons because its octet is complete on losing 1 electron only. So for that reason, our I3 is not simple I3 I minus, but instead it is I3 minus molecule. So I'm again telling it. So I3 doesn't mean that there are 3 negative charge, means uni charged, uni negative charge I minus or iodine, but instead of that you have a complete molecule which is I3 minus or a complete anion which is I3 minus, and that thing is made up of I2 and I minus. Okay, so I2 is coordinating with I minus to form this I3 minus, and it has a linear shape. And now since the overall charge on this I3 is -1, so cesium can simply neutralize it with +1, and our overall compound CSI3 is formed. Clear? Okay, moving on to the next question. Question number 10. Question number 10 says that bond order normally gives idea of stability of a molecular species. All the molecules, so whether you talk about H2, Li2, B2, have the same bond order, yet they are not equally stable. The stability order is, options are A, H2, B2, Li2, C, H2, Li2, B2, C, Li2, B2, H2, and D, B2, H2, Li2. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, what is the question? The question is saying that if you find the bond order of all these three using the MOT, you will find that all of these have the same bond order which is 1, but still they are not equally stable, right? Because bond order regulates the stability thing. Okay, so it says that if it is having a higher bond order, means it's stable. It is now lower bond order, it's less stable. But each of this is having the same bond order, and still they are not equally stable. So you have to search that what is the order of stability for all of these three. So the correct option is B. So the MO configuration, if you write, it can be written as H2 can be written as sigma 1s2. Okay, this is sigma 1s2. Li is sigma 1s2, sigma star 1s2, sigma 2s2. Okay, and your B2 plus is, your B2 is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and pi 2 px1, pi 2 py1. Here, now we can see here that although your bonding order is same, right? Bonding order is same, but your electrons are present in anti-bonding. This star here is representing the anti-bonding. And since this B2 is containing the largest number of electrons in the anti-bonding, therefore its energy is increasing and its stability is decreasing. Therefore, this order can be written as H2, Li2 and B2, where B2 is the least stable as it has 4 electrons in the anti-bonding orbital. Similarly, here lithium has 2 electrons in the anti-bonding orbital and hydrogen has no electrons in the anti-bonding orbital, so it is the most stable, although their bond order is same. Okay, so this is the reason for it. Moving on to the next question. Question number 11. Question number 11 says that which of the following compounds has the smallest bond order in its molecule? Your options are A, H2O, B, H2S, C, NH3, and D, SO2. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution first of all. So what is the question being asked? So this question is regarding the parameter, bond parameter, right? So it is asking about the bond angle. So out of these molecules, you have to see that which of these has the smallest bond angle, right? So the correct option is B. So here the smallest bond angle is of H2S because S atom is larger in size and low electronegativity, right? Why is it so? Because S atom is larger in size. So due to the low electronegativity, what will happen? Low electronegativity, most of the electron will be towards where? Towards the middle. Okay. And that would result in less repulsion and therefore the bond angle will be smallest. Clear? Okay. So again, I am telling it that since your sulfur is your sulfur that is present in as a central atom, so it is less electronegative. So most of the electron will be in the center, or you would also say that they will be more towards the as compared to all other, they will be more towards the hydrogen. So I am not saying that it will be towards the hydrogen. I am just comparing with all the other one and saying that compared to them, they will be more towards the electrons will be more towards the hydrogen. Now, as a result of this, there will be less repulsion around the nucleus of this sulfur and hence your bond angle will be small. Clear? And also the large size, because the large size will result in longer wave bond length and hence the electrons can be distributed more, you can say easily or more uniformly. That would result in less accumulation and less repulsion. Okay, moving on to the next question. Question number 12. Question number 12 says that arrange the following molecule in the increasing order of bond angle. Again, it's a question of bond angle. H2O first, second H2S, third H2SE, and fourth H2TE. So your options are A 1, 2, 3, 4, B 4, 3, 2, 1, C 1, 3, 2, 4, and D 4, 2, 3, 1. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So what we have to do, we have to see the increasing order of the bond angle. How we'll see it? So first of all, what is the correct answer? The correct answer is B. So you will simply see that lone pair and bond pair repulsion is maximum in case of H2E, H2T, that is your tellurium hydride, due to less electronegativity of tellurium, and minimum in H2O due to high electronegativity of oxygen. Okay, so the correct order is 4, 3, 2, 1. Okay, so I'm again telling it that the lone pair bond pair repulsion is maximum in H2T due to less electronegativity of tellurium and minimum in H2O due to high electronegativity of oxygen. So as a result of it, it will repel, and that will result in this bond order, which is 4-3-2-1. So the most will be H2T, then will be your H2Se, then will be H2S, and then will be your H2O. Clear? Okay. Now moving on to the next question. Question number 13. Question number 13 says that consider the following iodides, which are Pi3, whose bond angle is 102 degrees, ASI3, that is enstantine iodide, 100.2 degrees, and your SB, that is antimony iodide, which is 99 degrees. Now you have to see the bond angle is maximum in Pi3, which is the reason you have to say. Options are due to small size of phosphorus. Option B, due to more bond pair repulsion in Pi3. Option C, due to less electronegativity of phosphorus. And option D, none of the above. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, what is the question been asked? So you have to see that the bond angle is maximum in Pi3. And you have to find the reason. You will see it very clearly that this must be the order. Okay, SBI3 has the minimum one, then your ASI3, and then your Pi3. Clear? So the correct answer is B. Okay, correct answer is B. Why it is correct? Because P is more electronegative among the given option. Due to this, there is more bond pair repulsion. So how do we explain this, right? So it's very simple. So if your central atom is more electronegative, it will attract the shared pair of electron more towards itself. Now there is an accumulation of charges around the central atom, and to avoid that accumulation, because there is much more repulsion on accumulation, to avoid that repulsive force or to avoid that accumulation, the bond will move away from each other, okay, due to repulsion, and that will result in higher or larger bond pair angle. So that ring is written here that phosphorus is more electronegative among the ions. So due to this, there is more bond pair repulsion. Clear? Okay. Now moving on to the next question, which is question number 14. Question number 14. Question number 14 says that bond energy of HH, FF, HF are 104, 38, 135 kilocalorie per mole respectively. The resonance energy of HF molecule will be, options are A, 142 calorie per mole, B, 66 calorie per mole, C, 72.14 calorie per mole, and D, 79.26 calorie per mole. So you have 10 seconds to solve this question. Your time starts now. Now let us see the solution. So first of all, what is being asked here? So basically it is asked that your bond energy of three species are given, which is HH, H2, 104 kilocalorie per mole, FF or F2, which is 138 kilocalorie per mole, and your HF, that is hydrogen fluoride, that is 135 kilocalorie per mole. Now you have to see the resonance energy in HF molecule will be, you have to find the resonance energy. So the correct answer is C. How will solve it? So what is resonance energy? So it is the given by, if you are calculating the resonance energy, it is given by bond energy of HF minus root under bond energy of H2 into bond energy of F2. Okay. So this is the extra stabilization energy that is being reduced upon the resonance. Yeah, and that is being cut off in this way. You can see that this is the bond energy, and in this way we are cutting it off by taking the root also. Okay, we're taking the root because that would result in square, so we're taking the root. Now if you put all these values, that is 135 for this, okay, for H2 it is 104 and your B2 it is 38. If you put all this, you will get that 135 minus 62.68. So this value comes out to be 60.68, and your overall your overall resonance energy is given by 72.14 kilocalorie per mole. Clear? So in this way you will solve this question. Now moving on to the next question. Question number 15. Question number 15 says that the species in which the N atom is in a state of sp hybridization is? So options are A, NO2 minus, B, NO3 minus, C, NO2, and D, NO2 plus. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So first of all, what is the question here? So the question is asked here that among the various species of nitrogen that is given, in which of this case nitrogen is sp hybridized? Okay, so in which case nitrogen is having hybridization of sp? Now, so the correct answer is D. So this is the structure of all of this. This is NO2 minus. Okay, this is what is the hybridization of this? It is simply sp2. Okay, again, this is also sp2. Now, student may get confused in this type of thing. Why? Because it is a coordinate bond. Why do we consider it? Right. So you will also see such examples in case of BF3O82. So where the O82, which is our ether, is donating electron to the Lewis acid, which is BF3. Then in that case also we have seen that there is a change of hybridization. Means the adduct that is formed, or the adduct of BF3 and ammonia, right? That is boron trifluoride and ammonia. It also forms an adduct, and in that adduct also the boron will have a sp3 hybridization upon introduction of coordinate bond. Here also, since nitrogen is forming a coordinate bond, therefore it will also be considered in your hybridization, and your hybridization will be sp2. Next, again moving on to the next thing, which is NO and having a radical, that is again your what? It is again sp2 hybridization. Now the last one, which is NO2 plus, it is having a linear shape. This is having a linear shape, so it is having sp hybridized nitrogen atom or sp hybridization. Clear? Okay. Now moving on to the next question. Question number 16. Question number 16 says that the d orbital involved in sp3d hybridization is, your options are A, dxy, B, dzx, C, dz square, D, dx square minus y square. So you have 10 seconds to solve this question. Your time starts now. Okay. Now let us see how we can solve this question. So first of all, the d orbital means you have to see this. See, d orbital has 5 orbitals: dxy, dyz, dxz, dx square minus y square, and d square. These are the 5 orbitals d subshell has. Now you have to find that which one is involved in sp3d, because sp3d involves only one d orbital. And now one more thing, d orbital in case of in case of d orbital, all the orbitals are not having the same energy due to their different orientation and different type of shape, in which as compared to p orbital, where all three are having the same shape and the same size, therefore they all three can have the same energy, and we can take either of them, that is x, px, px, py, or pz. But in this case, since only one d orbital is allowed, and that d orbital is not accused, that d orbital should also be involved in this bonding. Okay, so how will we see it? So the correct answer is what? The correct answer is C. So why it is? So this is dz square. First of all, the answer is dz square, and it is involved in sp3 hybridization. Now why it is so? Because in sp3 hybridization, 1s and 2s orbital combine to form the triplanar trigonal hybrid orbital. The remaining p orbital may combine with dz square to form two axial bond orbitals. So it is being said here that the planar structure, that in your TVP you will see a triangular planar. So the triangular planar is formed by the overlap of 1s and 2p. And your dz square, that is your axial one, it is formed by the p orbital that combine with dz square. Now why are we taking dz square? The question could come that why are we taking dz square? So the reason is that your dz square is having only 2 lobes. Okay, except all the orbitals which are having 4 lobes, dz square has a 2 lobe type of setup. Now all the electron density is same, but it is not diffused among the 4 lobes, but is localized much upon the 2 lobes. Clear? Now what will happen as a result of it? As a result of it, what will happen? You will see that it will be very suitable to do the head-on-head overlap to form the say axial bond, right? So more the dz square, more the electron density as compared to xy and dz, whose electron density has been distributed along all the axes. As a result, it will be more appropriate to form the TVP, that is a triangular pyramidal. Clear? So this question is important, that you should remember always, that your dz square of out of all the 5 orbitals, dz square is involved in the sp3 hybridization, sp3d hybridization. So with this, we have completed this session. Thank you.